So number 16.
We just worked 16 yesterday.
I know, but some people didn't pay attention.
Yeah, that's all then.
So we have cosine squared x. This means the cosine of x squared times sine cubed x. So I'm going to write that as sine of x cubed. So when you do this derivative, this one has an x, and this one has an x, and they're multiplied together. So we have to do product rule. So product rule says derivative of the first. Okay, when you have multiple functions, you start on the outside. So the outside comes down, inside stays the same. Subtract 1 from the power, so it's to the first. But then we have to do derivative of the inside. So derivative of cosine. So this all represents the derivative of the first. Then we do times the second. Plus the first times derivative of the second. So the 3 comes down, inside stays the same, subtract 1 from the power, times derivative of the inside. Okay, clean it up as much as you can. So we have a negative and we have a 2, so that's a negative 2. Cosine x, sine times sine cubed will be sine to the 4th. Here I have a 3. Cosine squared times cosine is cosine cubed. And a sine squared. Is that one okay? Okay, 1 over t cubed, I'm going to write that as t to the negative third. So then the derivative. Again, this is a chain rule because we have an outside function, the cosecant, and we have an inside function, the t cubed. So we start on the outside. What is the derivative of cosecant?
Negative cosecant cotangent.
Inside stays the same. But then we have to do the chain rule, so that's the derivative of the outside right here, times derivative of the inside. So derivative of t to the negative 3 would be negative 3t to the negative 4.
Wait, I'm already kind of lost. So, wait,
Got it?
Yeah.
So this is just like a negative 1 times a negative 3, so it would be 3t to the negative 4. Oops. Cosecant. T to the negative 3. Cotangent. T to the negative 3.
okay, so when you do look at the derivative, you have to do it with the inside too.
Chain rule. Derivative of the outside.
And so when you do the derivative of the outside, you bring the t to the negative 3 in with it?
Yes, inside stays the same.
Oh, yeah. Wait, do you minus 1?
No, because it's not a power rule when you do a derivative of
Okay.
cosecant. Okay. So I have two things that are divided. So if we're dividing, we have to do the quotient rule. So that is low, the bottom one, so tangent 5t, times derivative of the top. Okay, so this top, what is the derivative of secant? Okay, when you do that, the inside stays the same. So it's secant 3t, tangent 3t. But then we have to do chain rule. So times derivative of the inside. What's the derivative of 3t? 3. So that's low d high minus high d low. So derivative on the bottom. Derivative of tangent is secant squared. We have to do chain rule, so times derivative of the inside. Derivative of 5t is 5. Over low square. As far as simplifying this, there's not a lot we can do. We can't cancel a tangent because this one has tangent 5t, but this term does not. I would like for you to go ahead and just pull your coefficients to the front of those terms. So 3 tangent 5t, secant 3t, tangent 3t, minus 5, secant 3t, secant squared 5t. Over the tangent 5t squared. Is that one okay? On this one, we aren't doing a product rule here. It's not secant times cosine, it's secant of cosine. So we have to do the chain rule. So you start on the outside. Derivative of the outside. What is the derivative of secant? Secant tangent. But when you do the derivative of the outside, the inside stays the same. So it's secant of cosine 3t times tangent of cosine 3t. We have to work our way in. So that's derivative of the outside, inside stays the same. Chain rule says times derivative of the inside. What is the derivative of cosine? Inside stays the same. What's the derivative of the inside now? The derivative of 3t. So all I would ask, if we pull the negative 3 in front, 21. Right, so it tells us f of x is f of f of f of x. And we want to find f prime of 1. So let's talk about this derivative. We have 3 different layers here. So we're going to do the chain rule, but we have to work our way in. So we start on the outside. Derivative of the outside will be f prime, and the inside stays the same. Work our way in. Times derivative of the inside, so I'm on the pink one now. So derivative of f is f prime, inside stays the same. Times, working our way in, derivative of the inside, derivative of the green one now. So that's another f prime. I'm telling you in this, I want f prime of 1. I change those x's to 1s. Alright. I have f prime of f of, what's f of 1?
2.
So that turns into f of 2, which is 3. And then I have f prime of 3, which is
6.
times. This one is f prime of. So f of 1 is 2. Then I have f prime of 2, which is 5. F prime of 1 is
4.
so I end up with 6 times 5 times 4, or 100. You like this?
That's why I did it.
You guys aren't asking questions. Are you understanding these as I go through them? An equation of motion of a particle is given by S equals the cosine of 2 pi t. Find acceleration. So here's position. What's the first derivative?
Velocity.
Oh.
How do you get acceleration?
It's a second derivative.
Okay.
I didn't know that's what that was. Now I know that.
First derivative. So we have to do chain rule. Derivative of the outside. So derivative of cosine, negative sine, inside stays the same, times derivative of the inside. What's the derivative of 2 pi t? So we just get negative 2 pi sine 2 pi t. Do we have to do the product rule here?
Yeah. No.
Why not?
Yeah.
You have to do the product rule if you have your variable multiple times. My only variable is t. So this 2 pi in front is just a coefficient. So when I do my second derivative, it just comes down. So we have a negative 2 pi. Derivative of sine is cosine. Angle stays the same. Times derivative of the inside. What is the derivative of 2 pi t? So I gives me negative 4 pi squared cosine 2 pi t. Did it give us, yeah, find the acceleration after 5 seconds. So what do we need to do now? Again, 5. So if t equals 5, 2 pi times 5 would be 10 pi. And think about your unit circle. Every time you go around, that's 2 pi. So 2 pi, 4 pi, 6 pi, 8 pi, 10 pi. We're just right here. If you think about ordered pairs, that would be 1, 0. Cosine is the x. So cosine of 10 pi is 1. All right, this would be an excellent multiple choice type question on your test. What you need to remember, a derivative is a rate of change. The 10, that took the place of the r here. R was percent, so that's like saying 10%. A derivative is a rate of change, and f is measuring the cost of repayment. So what this means is when the interest rate is 10%, the f, so cost of repayment, is, it does not say the cost is a flat 1,200. What does the 1,200 mean? Okay. And since it's positive, we could say increasing by. $1,200 per year. So it tells me when the interest rate is 10%, my cost is going up $1,200. It doesn't tell me what my actual cost is, just how my cost has changed. You guys understand the difference there? T4. Okay, so we have something roughly like that. What we know is that anywhere the function has a maximum or minimum, the tangent line would be horizontal. So what does that mean the derivative is equal to? 0. 0 here, and here, and here. My graph was increasing. So what does that tell you about the derivative? Positive. My graph was decreasing. So the derivative? My graph was increasing. So the derivative? And then decreasing, so it's back to negative. So what I'm looking for on those would be, do you have your zeros in the correct spot? Do you have the correct positive or negative? All right. Look for what else?
That's probably why I got the right answer.
25 said,
I don't even know what that means.
use the definition of derivative.
I don't know what that is.
The very first stuff.
Yep, this was section 2.7, the definition of derivative. So we had
H and A.
So we did, there were two different versions. Probably the easiest is the limit as h approaches 0 of f of x plus h minus f of x all over h. Alright. So if I say do a definition, we have to do this whole thing. So the limit as h approaches 0. F of x plus h says go to your function, replace your x with x plus h. So that would be 4 over 3 plus 2x plus 2h. Can I just go ahead and distribute that to f of x plus h? So you're replacing that x with an x plus h.
Nice here.
Okay.
Minus f of x. So f of x is the original. All over h. Now our goal is to get to the point where we can plug in 0 for h. Can I do that right now?
Nope.
No. So what we did is we got a common denominator. So this one had 3 plus 2x plus h. This one just had 3 plus 2x. So you take the first fraction times 3 plus 2x on top and bottom. Second one. I'm not going to multiply that all out, I don't think. Okay. So now on the top, these denominators are the same. So I can distribute this negative and put those fractions together. So if I combine them, the 12s drop, 8x's drop. So we get negative 8h over the denominator. I'm also going to write this divided by h. That's like an h over 1, so you can flip and multiply by 1 over h. What happens there? H's cancel. And that got rid of my problem. So now I can plug in 0 for my h. So we get negative 8 on top. On the bottom, we have 3 plus 2x times a 3 plus 2x, or I'm just going to write it as 3 plus 2x squared. Should we try another?
Yeah.
Yeah.
Alright.
I got the same answer. Just want you to know.
You can use the rules like that we know now to check yourself. There will be one on your test. It will be, I will say, use the definition of derivative. Now, you can check yourself using the other way, but the one time I ask you to use the definition, you need to actually work it out like that. Let's do a polynomial. Okay. So if I said, use the definition of derivative. So we have to do the limit as h approaches 0. F of x plus h means you go to your function. You are replacing your x's with x plus h. Minus f of x, so that's the original. All over h. All right, so let's just multiply it out. Okay, can I FOIL this and distribute my 2 at the same time?
Yeah.
So we would get 2x squared, 4xh plus 2h squared. Distribute the -3, so minus 3x minus 3h minus 2x squared plus 3x. And then we see 2x squareds drop, 3x's drop. Everything that's left has an h in it, so we could reduce an h. So we get a 4x plus a 2h minus 3. And now if you plug in a 0, you get 4x minus. Which, if we just did the power rule, is that the correct derivative? Yeah. Okay. I want to try something with an E in it. We haven't done any of those today. Is this one all right? What if I said okay, what if I gave you this? What would we have to do here?
The product, we'll like move it in the product.
Yeah, you have 2 options. You can move it up and make it an e to the -5 and do product rule, or I think, Bo, you said quotient rule, right? Is that what you said? Okay. So either one works. We've done more product rule problems today. Let's do a quotient rule. If you did already started at product rule, that's fine. I don't care. So quotient rule is low d high. What is the derivative of e to the x? Minus high d low. Derivative of the bottom? Over low squared. So x to the 5th squared becomes x to the 10th. What can we do right here?
Take out some x's.
We can reduce 4 of them. So we're left with x e to the x minus 5 e to the x over x to the 6th. Is that okay? So the square is on the x, not the sine. So what do we have to do? So that's low. D high, derivative of cosine. Minus high. D low. Alright, on the bottom, derivative of 1 is 0. Minus, derivative of sine is? Angle stays the same, but you would have to do a chain rule, so times derivative of the inside. What is the derivative of x squared? 2x. Over low squared. Not a ton you can do to simplify here. You could go ahead and multiply out on top. You would have a negative sine x. Actually, that's really not even going to be pretty because the angles aren't the same. So I probably wouldn't even do that. I would ask that you pull the negative out in front at least. Pull this negative and the 2x to the front. But that's about all we can do there. Make sure you look over and know the derivatives of all of your trig functions. What if I gave you what would you do?
Change the radical to negative 1/2.
This would be 3x minus 4 to the negative 1/2. What about the cube root of x minus 1? What would that be? Do I need to change the square root of 5? No, it's just a constant. So when you do your derivative, 3x minus 4 to the negative 1/2. The negative 1/2 comes down. Inside stays the same. Subtract 1 from the power, so now it's the negative 3/2. What else do I need there? Derivative of the inside is a 3. Plus 1/3 comes down. X minus 1, subtract 1 from the power. What's the derivative of the inside of that one? Plus, what's the derivative of the square root of 5? 0, because it's a constant. So all you could really do is combine coefficients. That would be like negative 3/2. 3x minus 4 to the negative 3/2. what else? Anything else specific that you want? Practice.
I'm just really confident.
Good.
Can't say the same, I just can't think of anything.
Make sure though, guys, you don't just like not think about this again until you walk in to take the test. You know, please look back over it, watch this video, come in and get some review problems during advisory Monday, something so we don't lose it and that we are okay going with this. Are you doing anything else? We still have a little bit of time.
Like 8 minutes, so you can,
Yeah, need to do something. Can't stop yet.
okay.
Alright, if I ask you to write the equation of a tangent line, what do you have to do?
Derivative.
Derivative, and then I'll give you some kind of point, so you have to plug that in to get your slope. And then do y equals mx plus b. Do I need to work through one of those?
I can't see what else we would be doing right now, so.
Like, I don't know, maybe sine?
Another trig function?
No, I'm kidding, it'll be fine. I just mess them up.
Okay, so like I said. What are you doing? You guys know how to do second derivative. You're done. Alright, try this one. Try it on your own. How'd you guys do? Got it?
That is not what I did at all. I don't think my brain is here actually anymore. Just, I already know what, I know what I'm doing, I just didn't do